All right, looks like everybody's back. So hopefully you had some fun playing with the hanger diagrams and thinking about how you can work with students to build their understanding of what an equation really is. It's amazing how far students can get in mathematics when some of the big concepts end up being just mechanics and that they don't really have the concept. So it's one of the things I love about hanger diagrams. Okay, so the next lesson, lesson 6, is called Playing Catch Up. And it's a Desmos activity that was developed from a fun video that was actually comes from, I'm not sure if it's Sports Center, but it's something similar to Sports Center, if not exactly that. And so I am going to share in the chat a link for you. And this brings up the idea of sharing videos with students, particularly when you're virtual. So in your classroom, you know exactly what you would do. You would pop it onto your screen and make sure you had sound and it would be all set. When you do it virtually, you can do it that way. You have to make sure that you have your computer set to share the sound of a video. But quite often you run into bandwidth problems. And so another option is to just share a link to a video for your students and to let them go to it themselves. So you'll find throughout the course in Modeling Our Role with Mathematics that we use videos. They're a great way to grab kids' attention, particularly with the contexts that we're working with to develop the mathematics. And we haven't used a lot of them here. We've talked about 1 or 2 of them, but we didn't want to take the time here to have you watching videos when we want to do this synchronous session. But consider that if you want students to watch videos or things like this, these are great things for them to do in asynchronous time. And so they're very willing to watch videos on their own. So it's a great way of engaging them, getting them interested. And then when they come back, you can pull out the pieces of what's important from that video. Or in this case, we pulled it apart for you and developed a Desmos activity. And I guess this one actually was done by Desmos, the company. We didn't do this one. We did some of them, but not this one. Okay, and so then moving on, the next lesson, gym membership. The launch for that gives students the opportunity to do a notice and wonder again. And this, the first notice and wonder they did was not very mathematical at all. The second one had a bit of math in it. This one, you're using the notice and wonder to really dive in on the mathematics. And so students, again, still have the accessibility of a low level entry, but I want you to think a little bit more mathematically this time and take just 30 seconds or so. What do you notice and what do you wonder? All right, so let's just, and I'm going to ask everybody to put one thing they noticed in the chat, but don't hit return yet. Just type the statement, but don't hit return. And then one way to see how many students are truly engaged and thinking for themselves rather than just getting something from the learning of others is now everybody hit return all at one time. And all of a sudden we have this just explosion of things that come into the chat, which as a teacher, you can save the chat and you can see who contributed what. So it allows you to go back later and take a look at what students put in there so you can assess their understanding and their engagement for students. I won't talk about busting students for not engaging, but it's one way to catch them so that you can redirect and encourage them. That's what I meant to say. Okay, so the things that I see, we see solid and broken lines or solid and dashed lines. We have 4 distinct areas, 2 inequalities with shade and regions. We have no units offered. We have a comment on where the lines intersect. It's one graph. There is an overlap. Okay, and so then the wonderings start to show up. What does the overlap part mean? What are other things that students might wonder about? Feel free to toss one in the chat. What do the inequalities represent? What are the units? Why is one line solid and one dashed? I can tell you that I've told students numerous times when you use a solid line and when you use a dashed line, and as soon as they walk out the door, they forget. But if they've asked the question and they wondered about it themselves, then all of a sudden they're like, oh, yeah, I remember that. So it helps if the students ask the questions, then they own the questions, and it really helps them out. Okay. So there's a variety of things there. So just a quick example of what that might be like. Okay, also in this lesson, we take a look at 3 different gym memberships and decide which gym membership is the most beneficial for different participants. And so in a Desmos activity that we offer, students can take a look at, is it better to pay a larger price and a lesser visit cost, or is it better to have no cost at all to join, and what does it look like for different prices and things? And they actually look at different situations and get the opportunity to make that decision. In lesson 8, they reason more about systems of equations, and it connects back to those hanger diagrams again. So they look at that, and we look at not just hanger diagrams as equations, but as systems of equations, and gives students a better conceptual understanding why adding 2 equations works, why that's an okay thing beyond your teacher said you can do it.